let's take a look at multiplying and dividing complex numbers. For example 6, we're just going to multiply numbers. We'll divide when we get to later examples. So let's take a look at finding each of these products. Now, when you have a binomial multiplied to a binomial, I think most of you have heard that acronym FOIL, right? First, outer, inner, last. And that's all fine and good, but I actually prefer saying I'm going to double distribute. So you're going to see me double distribute. And the reason I like distribution better than foiling is foiling only works when you have a binomial and a binomial. It doesn't work. We don't have an acronym for a trinomial and a trinomial, or a trinomial to a binomial. It only works in this case. So that's why I like to double distribute. So you're just going to watch me double distribute. If you prefer to foil, go for it. We'll all wind up at the same spot. So I'm going to distribute the 5 to the 2 minus 7i, and I'm going to distribute the 3i to the 2 minus 7i. So I'm going to distribute 5 to 2 minus 7i. I will add to that 3i to 2 minus 7i. And let me keep distributing. So we've got 10 minus 35i. This looks like plus 6i minus 21i squared. Now you have a couple of options here. If you prefer, you can add the like terms. The way my brain functions, I always just, whenever I see an I squared, I immediately think, you know what, let me just swap that out with -1. So for me, I would just do 10 minus 35i plus 6i. Now 21, or I should say -21 times a -1 is actually positive 21. And then I look for like terms. So I'm going to look for like terms. I see 10 and 21, so that's going to give me a 31. I see negative 35i and 6i, so that would ultimately be negative 29i, right? So I added the real parts and I added the imaginary parts because those were like terms. And there's my answer in standard form, a plus bi. All right, great. Let's take a look at b. I'm going to put a little squiggles there just to have some division between the two examples. Now I want to talk about this expression. So a common error I see among students is that you see this binomial squared and you distribute this squaring to the 4 and the 5i. And so what I see frequently from folks is an answer of 16 plus 25i squared. And then maybe you change this over to a -1 and you tell me the answer is -9. And ultimately though, even if you do that algebra correctly after you square this, it's incorrect. You're not allowed to distribute an exponent over addition or subtraction. You can only distribute an exponent over multiplication and division. So you're not allowed to do this, which means even if you do the algebra correctly after this part, it doesn't matter because you were wrong in going from this step to this step. So be careful. You cannot distribute an exponent when there's a binomial there, meaning there's addition or subtraction inside of those parentheses. And the reason is you're missing the outer and inner terms. So let's go a step at a time so that we can see what the answer should have been going through this. If I have 4 minus 5i squared, I have 4 minus 5i times 4 minus 5i. Now again, if you want to FOIL, great, go for it. I'm going to double distribute. So I'm going to distribute the 4 to the 4 minus 5i, as well as the minus 5i to the 4 minus 5i, right? This term gets multiplied to these two. This term gets multiplied to these two. That's what double distribution looks like. So let me keep distributing. I've got 16 minus 20i minus 20i, and this will ultimately be plus 25i squared. Right? So you see the 16 and the 25i squared, which I initially had written up here, but you see the outer and inner terms. When you distribute that exponent just to these two terms, you're ignoring the fact that you had outer and inner terms. All right, so there's my I squared. So I've got 16 minus 20i minus 20i. All right, positive 25 times -1 will be negative 25. So I see some like terms of 16 minus 25. We got -9. Negative 20i minus 20i, I think I'm looking at negative 40i. So there's my answer in standard form, right? A plus bi, I'm good to go. All right, C is special. So we want to talk about C here because something unique will happen with this product, and what happens with this product we're going to use in example 7. So I want to look at our two binomials in here. You see 9 minus 8i and 9 plus 8i. So the binomial here and the binomial here, they're very similar. They both have 9s and they both have 8 eyes. The only difference is this has a subtraction symbol and this has the addition symbol. So when you have two binomials that have the same number or the same term in the first position and in the last position, and they only differ from each other in the signs that are here and the operations that are here, they're opposite or inverse operations, addition and subtraction. When that's the case, these are called conjugates of one another. So 9 minus 8i is the conjugate to 9 plus 8i, or you could say 9 plus 8i is the conjugate to 9 minus 8i. Now something very unique happens when you multiply conjugates. So I'm going to double distribute these. Again, if you want, go ahead and FOIL them, but I'm going to double distribute them, and then we're going to talk about what was special about these products. So if I double distribute, I'm going to go 9 times 9 plus 8i, and then I'm going to distribute the negative 8i to 9 plus 8i. All right, so looking at this, it looks like 81 plus 72i minus 72i minus 64i squared. All right, again, my I goes right to, no pun intended, but my I, like EY, my I goes right to I squared. All right, and I'm going to swap that out with negative 1. So I've got 81 plus 72i minus 72i. Negative 64 times negative 1 is positive 64. And I want you to take a look at the outer and inner here. And if you had foiled these would have been your outer and inner. You see positive 72i and negative 72i. They cancel. All right, and with conjugates, that will always happen. If you look at the outer, it's positive 72i, the inner is negative 72i. Because these numbers are the same in magnitude, right, 9s and 8s, they're just different in signs. One is positive 72, one is negative 72. These will always cancel. And ultimately, 81 plus 64 is 145. Now, why this is special and why we're going to use it later is because I want you to see you started with complex numbers, right? If you look at these binomials, you started this problem with complex numbers, right? I had a real and an imaginary part, a real and an imaginary part, complex numbers. But look at where you ended up. There are no imaginary parts here. You ended with a real number. And if you remember, I is a radical, right? It's the square root of negative 1. So really, you started this problem with some radicals and you ended without them. And that's going to become important when we look at dividing complex numbers in the next example. All right, I'll see you in a bit. Bye.